Alright, today we're going to start looking at the complements of sets. And what the complement is it's everything that's not in a set. So if we look at the natural numbers from 1 through 20 and its subsets, here what we're saying is that U, or our universal set, is all x such that x belongs to the integers, so x is an integer, and x is 1 through 20, and it includes 1 and 20. So x is greater than or equal to 1 and less than or equal to 20. So that's the natural numbers from 1 to 20. We use the symbol U to represent our universal set. So our universal set is the biggest set that we're considering for those problems. And so our biggest set here is the natural numbers from 1 to 20, so we call that our universal set. So then the complement of A, and we write that like A prime with a little apostrophe, is the set of all elements of U that are not in A. So if we take a smaller universal set now, so instead of saying the natural numbers from 1 through 20, we're saying U is the natural numbers from 1 through 8. And we're going to say that A is 1, 3, 5, 7, and 8. Then the complement of A, or A prime, would be everything that's in our universal set, everything in U that's not in A. So 1 is in A, so it's not in the complement of A. 2 is not in A, so it is part of the complement of A, or what we call not A. I like to just refer to the complement of A as it's not A. It's whatever's not in set A. So there's three relationships that are observed when we talk about A and A prime. These are that the intersection of A and complement of A is the empty set. And if we go back to the previous notes and look at the previous notes that you just took on where the universal set were the numbers 1, 2, 3, 4, 5, 6, 7, and 8, and A was 1, 3, 5, 7, and 8, and the complement of A was 2, 4, and 6. Notice that A and the complement of A had nothing in common. So the intersection, the things that were in both sets, is nothing. So that's where our empty set comes from. And then the union of A and the complement of A, if we take everything that was in A and we take everything that was in the complement of A and we put it back together, we got our universal set back. We got the whole set that we started with, which were the integers from 1 through 8. And then if you take the number of items that are in set A, the number of elements in set A, which was 5, and we add to that the number of elements that were not in set A or were in the complement of A, then we get the number of elements that we started with back in our universal set. So these two are kind of related. It's just one is related to the actual sets. If we add A and the complement of A, we get our universal set. And the second one has to do with the number of things in each set. So if we take the number of things in A, the number of things in the complement of A, we add them together, we get the number of things we started with. Okay, so we want to find the complement of C, given that the union is all positive integers. Or not the union, the universal set is all positive integers. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, on and on and on. And C is all even integers. So that's 2, 4, 6, 8, and on and on and on and on and on. So we want to know what is C, the complement of C for A. If we have the universal set is all positive integers and set C is all even integers, then the complement of C has to be all odd integers. So what is in the complement of C is everything that's not in set C that is in set U. So then if we look at the second one, C is going to be the set of all x such that x is an integer and x is greater than or equal to 2. So it's going to be, if we look at C for part B, it's going to be 2, 3, 4, 5, on and on and on and on, all the integers greater than 2. And the universal set is all of the integers. So everything that's an integer, period, is in the universal set, and then set C is the integers greater than or equal to 2. So then what's in the complement of C are all the integers less than or less than 2. So we would have the set of all x such that x is less than 2, or you could put less than or equal to 1, and x is an element of the integers. So either less than or equal to 1, because that's going to be 1, 0, -1, -2, -3, -4, -5, or you can just say less than 2 because we wouldn't include 2. Okay, so here we have the universal set, and to me it helps if I write everything out long ways. So if I take my universal set is the set of all x such that x is an integer, and x is greater than or equal to -5, and less than or equal to 5. So -5, -4, -3, -2, -1, 0, and then 1, 2, 3, 4, and 5. So that's my universal set. And then A is the set of all x such that x is an integer and x is greater than or equal to 1 and less than or equal to 4. So A is going to be 1, 2, 3, and 4. And then B is the set of all x such that x is again an integer and x is greater than or equal to -3. So B and less than 2. So B is going to be -3, -2, -1, 0, and 1. We don't include 2 because it's less than 2, not equal to 2. So here's our set A. That's 1, 2, 3, 4. We found it right here. So part A, the answer is right there. Part B, that's right here. We found that. What's in set B? Now, the intersection of A and B is what's in one that's in the other. So if we look, the only thing that's in A and in B is 1. So the intersection of A and B is 1 because that's the only element that's in both. Now, the union of A and B is going to be everything that's in both of those. So that's going to be -3, -2, -1, 0, 1, 2, 3, and 4. Those are negatives. And then the complement of A is going to be everything that's in U that's not in A. Because now we're back to looking at our universal set. So whatever is in the universal set that is not in A. So what's not in A is -5 through 0. So we would have -5, -4, -3, -2, -1, and 0. Then what's not in B is going to be everything that's in our universal set that is not in B. So I'm going to write that over here because I'm starting to kind of run out of room. So that would be -5 is not in B. -4 is also not in B. And then we have -3, -2, -1, 0, and 1 are in B. But then we have 2, 3, 4, and 5 that are not in B. So this one is the answer for part D. Then we have G, which is not in A intersects B. So here's our not in A, which is right here. -5, -4, -3, -2, -1, and 0. And then here's our B right here. And we want to know what intersects. So what's in both of those? Well, -3 is in both of those. -2 is in both of those. -1 is in both of those. And 0. So that is going to be the set -3, -2, -1, and 0. And then the last one is the union of everything that's not in A and everything that's not in B. So here's our not A, and here's our not in B. And if we take the union of everything not in A and not in B, what we end up with is our universal set. Because we're taking everything that's not, except for 1, so it's not the universal set actually, because we're missing 1. So everything that's not in A is here, and everything that's not in B is here, and so is right here. Not B is right here, and not A is right here. So we're going to take all of those and put those together, and I'm going to write that right here. So we have -5, we have -4, we have -3, we have -2, we have -1 and 0. We don't have a 1. There's no 1 in either of those sets, but we do have 2, 3, 4, and 5. So that would be the union of A, the complement of A, and the complement of B. So then this is, suppose the universal set is positive integers. Suppose set P is multiples of less than 50, and set Q is multiples of 6 less than 50. So we end up with set U. If I list that out, it's going to be all the positive integers. So we get 1, 2, 3, 4, 5, and then it just continues on and on. P are multiples of 4 less than 50, and part A asks us to list those. So less than 50 multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. And then set Q is going to be multiples of 6 less than 50. So 6, 12, 18, 24, 30, 36, 42, and 48. So there's the universal set, set P, and set Q. So now it says find the intersection of P and Q. So the intersection are the things they have in common. So if I look, they have a 12 in common, right here and right here. So 12 is one of them. Then they have a 24 in common. And then they have a 36 in common. And then they have a 48 in common. So the intersection of P and Q is 12, 24, 36, and 48. So then it says find the union of P and Q. So that's everything together that's in P and Q. And I'm going to write that here. So we have 4, 6, 8, 12, 16, 18, 20, 24, 28, 32, or 30, 32, 36, 40, 42, 44, and 48. So all we're doing is taking everything that's in both of them and dumping them together. So then it says verify that the number of items in P union Q, which if we count those is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 items in the P union Q is equal to the number of items in P, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus the number of items in Q, which is 1, 2, 3, 4, 5, 6, 7, 8. So 12 plus 8, minus the number of items in our intersection up here, which is 1, 2, 3, 4. So minus 4. So we're supposed to verify that 16 is equal to 12 plus 8 minus 4. 12 plus 8 is 20, minus 4 is 16, so 16 equals 16. So that is a true statement that the number of items in P union Q is equal to the number of items in P plus the number of items in Q minus the number of items in the P intersects Q. All right, we're going to fly through these Venn diagrams pretty quickly. A Venn diagram consists of universal set represented by our rectangle. So whatever U is our rectangle. And then we have a set A here. And then all of this on the outside is the complement of A, or everything that's not in A. So the sets that we have represented here are the universal set, which has everything in it, 2, 3, 5, 7, and 8. Then set A just has 2, 7, and 8 in it. And then the complement of A has what's not in set A, which is 3 and 5. So subsets. We talked about to be a subset, everything in one set has to be inside the other set. So if B is a subset of A, then every element of B is in A. So here we have our subset B. Here's our set. And notice the entire thing is enclosed inside set A. That's how it's represented on a Venn diagram. The intersection we talked about consists of all elements that are in both A and B. And so that is just exactly what it sounds like. It's where these two sets or circle regions intersect. The union is when we take all of A, all of B, dump it together, so then the entire shaded region is the union, because it's everything in set A, everything in set B, and that includes what's in the middle. Disjoint, or that says mutually exclusive. I don't know why that cut off. But disjoints don't have common elements. They have nothing in common, so their circles are completely separated because nothing is from one is in the other. So here we have, suppose U is 1, 2, 3, 4, 5, 6, 7, and 8, and we want to illustrate on a Venn diagram A and B. So here's our U for part A. Here's our union, our universal set. So then we have set A has 1, 3, 6, and 8, and B has 2, 3, 4, 5, and 8. So they both have an 8 and they both have a 3. So they are going to have an intersection. So we're going to draw them this way. Here's set A, here's set B. 3 goes in the intersection and 8 goes in the intersection. 1 goes in set A, 2 goes in set B, 4 goes in set B, 5 goes in set B, and 6 goes in set A. Now, notice what we're missing. We have 1, 2, 3, 4, 5, 6. We don't have a 7, and 7 is in neither of those sets, so it goes on the outside, just part of the universal set, but not part of either of our subsets. All right, and then for B, we're going to do the same thing. We're going to draw our universal set. And we have 3 that's in both of them, 6 is in both of them, and 8 is in both of them. So notice that B, everything in B is completely enclosed inside set A. So we're going to have set A, and then we're going to have set B. And inside set B are 3, 6, and 8. And then 1 and 7 are in set A. And notice we're missing 2, 4, and 5. All right, next example. We have the universal set, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we want to illustrate set A and B, where A is 2, 4, and 8, and B is 1, 3, 5, and 9. Notice they have nothing in common. So these are going to be disjoint sets. They're not going to overlap at all. We're going to put 2, 4, and 8 inside set A, 1, 3, 5, and 9 inside set B. And then we need to figure out what goes in the universal set. So we have our 1, 2, 3, 4, 5. We're missing 6 and 7. So we'll put 6 here and we'll put 7 here. All right, so Venn diagram regions. In this one, set A is shaded. Notice the entire circle A is shaded. Here, the intersection is shaded, what they have in common. Here, not B is shaded, or the complement of B, because everything but B is shaded. We have B here that's not shaded. so not B, or the complement of B. And then this region over here is the intersection of B or of A and the complement of B. So is what's shaded. So we look at what do the complement of B, which is everything not in B, so that would be this one right here. What do that and A have in common? And if we do this correctly, say I now take and I'm going to shade in this A region over here. Now what the intersection is the things that are in the pink and shaded blue, which is this area right here, which is exactly what we shaded on the other one. Just a little bit to get down correctly. So we want to shade in, we have set A and set B, and we want to shade in their union. Well, we've already talked about that. That's everything that's in A and everything that's in B. So this would be the union of A and B shaded in. Then here we have the complement of A intersects B. So here's set A, here's set B. And one way you can do this is to shade different colors. So if I shade the complement of A in red, so that's everything that's not in A. So I'm going to shade everything that's not A in red. And then I'm going to go back and in blue, I'm going to shade in B. So this is all B here. And then we look at what shaded both colors. Well, this part is what shaded both colors. Right here, so that's what we're going to shade for our intersection, is this part here. That's what was shaded two different colors. All of this out here was just shaded red, and then this middle part was just shaded blue. And then our last one is A intersects B, but then I want everything but that. So here's A, here's B, and this tells me, okay, I want the complement of A intersect B. Well, A intersect B is this section right here, and if I want everything but that, then I'm going to shade everything all around that. So this would be the complement of A intersects B.